Okay, guys, so like I said, today we're going to be talking about parabolas in a little bit different light, okay? We're going to be talking less about the equation so much and more about, like, what is a parabola. So I asked you to spend some time taking a look at this parabola, okay? And trying to come up with some ideas about what you notice about the parabola in relation to this red dot and this red line. So what are some of the things that you came up with? Is there anything you noticed? Yeah. Okay, so the distance from the dot to the parabola and the parabola to the line are the same. Would you agree with that right here? Is the distance from here to here 1 unit? And from here to here 1 unit? Yeah? What if we go out here? What's that distance? 2. And what's this distance? 2. Okay? Now we're stopped being able to see this dot up here. But if you think of this as a oh, sorry, hard to draw sideways. Think of this as a right triangle, right? Instead of doing the distance formula. What kind of right triangle is this? 3, 4, 5, right? So would you agree that this distance is 5? And then what's the distance from here to here? 5. Oh, man. So that's what a parabola is, okay? A parabola is a set of points that are equidistant from a point that's fixed and a line that's fixed. And I'm going to give you names for both of those things, okay? So go ahead and switch to your notes page. All right, so the definition of a parabola is the set. Sorry, I gotta make that smaller. Of all points equidistant. What does that word mean? Same distance. Equidistant to a fixed point and a fixed line. Now, the fixed point is called the focus point, and the fixed line is called the directrix. The set of all points equidistant to a fixed point, which is called a focus, and a fixed line, which is called a directrix. So today and tomorrow only, really, we're going to be talking about both quadratics that are functions and not functions. Okay? We're going to be talking about both the parabolas we've been used to seeing, okay, up and down parabolas, and we're going to talk about horizontal parabolas, parabolas that open left and right. Okay? So, first let's talk about the ones we are comfortable with. Okay? That is a vertical parabola. And in a vertical parabola, we are used to seeing. Okay? It opens up or it could open down. Okay? This is the equation we are going to be using for these next 2 days. They're kind of weird, but it's just another way of thinking about vertex form. Okay, that's all it is. Another way to think about vertex form. The only thing that's really changed is that our A value is now represented by this 1 over 4p. Okay? Our A value is now represented by 1 over 4p, where p is the distance from the vertex to the focus. Okay? So this distance right here, that's our p value. Okay? From the vertex to the focus, which means what also has a distance of p? Good. The vertex to the directrix also has a distance of p. Okay? Couple things you might want to jot down or remind yourself. Your parabola will always open in the direction of the focus. Okay? So if the focus is above the vertex, your parabola is going to open up. If your focus is below your vertex, your parabola is going to open down. Okay? What can you tell me about the relationship between the axis of symmetry and the directrix? Yeah. The axis of symmetry and the directrix are always going to be perpendicular. Because one's always going to be vertical and one's always going to be horizontal. We're not talking about any rotated parabolas, just vertical and horizontal. Okay? So, important thing. If P is positive, then that would mean that 1 over 4p is positive, right? Would you agree with that? If we plug in a positive value for p, then 1 over 4p is going to be positive. And we said 1 over 4p is the same as our a value, right? So when a is positive, which way does our graph open? Up. So what do you think the flip side of that is? Yeah, if p is negative, then 1 over 4p is also negative, which means that a is negative, which means that the graph opens down. Okay? So let's give this a little bit of a try. All right, next to this, I'm going to rewrite our equation, our formula. Y equals 1 over 4p times x minus h squared plus k. Now, you should recognize that. That's our vertex form, right? We recognize that as vertex form. The only thing new here is that we've got this 1 over 4p instead of a. Okay? So, what is our vertex? 4, 1. Good. All right? Let's do our easy one first. Here's our vertex. So what is our axis of symmetry? That's the one we've been used to doing. Good. X equals, it's the vertical line through our vertex. Sorry, I can't see where the cursor is, so I can't tell where I'm writing. So I apologize that it looks all crazy. Okay, now let's talk about the two new things we've talked about, focus and directrix. To figure out where our focus and directrix are, we have to use this 1 over 4p. Okay, so 1/8 is equal to 1 over 4p. What does that tell me that p must be? Good. Everyone okay with that? All right, so p, remember, is the distance from the vertex to the focus. And p is positive here. So to get to my focus, I'm going to start at my vertex, and I'm going to go up 2 units. Let's try that again. So where is my focus? 4, 3. All right. My directrix is going to be what kind of line? A horizontal line, and this time it's p units in the other direction from my vertex. So I'm going to go down 2 units, and that's going to put me at y equals, oh my gosh, y equals -1. I look like a 4-year-old. Okay, now all that's left to do is draw in our parabola. Yes, ma'am. I'm sorry? Because the y equals -1 is the equation of this line right here, of the directrix. Okay, because it's the same distance on the other side of the vertex. Okay? Now I'm going to draw in my parabola. My a value was 1/8. Does that mean my parabola is super narrow or super wide? Super wide, because it's a vertical compression, right? So I'm going to draw, doesn't have to be perfect, but I'm going to draw a wide parabola through my vertex. I ran out of space, but yours can be equal on both sides. Make sure you go through the vertex, though, not the focus. Go through the vertex, not the focus. All right, let's flip to the back. I'm going to give it a try over here, see if it's a little bit easier. All right, now horizontal parabolas. A little bit different, okay? In a horizontal parabola, our parabola is either going to open left or right. Okay? Axis of symmetry is going to be parallel to the x-axis, and graphs are not functions. This is the first time we studied something not a function this year. Okay? Graphs are not functions, which means they will fail the vertical line test. All right, so here is our equation. Notice it's x equals, right? It's not y equals, it's x equals. X equals 1 over 4p times y minus k squared plus h. Okay? So the one we're used to, the one we've been doing, that's y equals, because all of the equations we've ever studied this year have been y equals, right? Now, when it's going to be sideways, it's going to be x equals. Okay, so important things to know. Your vertex is still h, comma, k, meaning the opposite of that k value you see in here. Okay, so h, comma, k. This time, your axis symmetry is a y equals, and your directrix is an x equals. Okay, it's vertical. Still, however, from here to here, that's what value? That's our p value. And from here to here, that's also p. Okay, if p is positive, which way do you think our parabola is going to open? To the right or to the left? To the right. Good. If P is negative, which way do we think our parabola is going to open? To the left. Just like up versus down, right versus left. All right. Shall we give it a try? Sure, yeah, that sounds great. Cool, okay. All right. First thing immediately, when you look at this, and as you're looking at them from now on, is the first thing you have to decide is if your parabola is horizontal or vertical, and if it opens in the positive or the negative direction. Okay? So look at this number 2. Notice that we have an x equals. Do you see that? When we have an x equals, that immediately tells us it's what kind of parabola? Horizontal. Good. Then look at your a value. Your a value is negative. So is this going to open to the right or to the left? To the left. So what I would highly recommend you do is draw yourself a little sketch right then and there to help you visualize everything. Okay? Because you got to visualize which way is your axis of symmetry going, which way is your directrix going. It gets a little strange. Okay? All right, so let's get our vertex, or vertex, as apparently I typed here. We got to be careful, because remember, it's h comma k. So think about our equation. I'm going to kind of try and write it in here. X equals 1 over 4p times y minus k squared plus h. All right, so our vertex, what do you think? What's our x value? What's our h value? -3. What's our y value? -1. Good. Why -1? Good. Inside the parentheses is the opposite. Okay. It's a little tricky. That's new to us, so we got to keep practicing that a little bit. Okay. So let's plot that. -3, -1. Now, we know that this parabola is going to open to the left, right? So what does that mean for our axis of symmetry? Is it going to be a horizontal or vertical? Horizontal. It's going to look like that, right? So what would our axis of symmetry be here? Good. Y equals -1. So we have a horizontal parabola this time. Okay with that? All right. Now let's find our focus and our directrix. In order to find our focus and our directrix, we need to use what information? A, right? A is -1/4, and that means that is equal to 1 over 4p. So tell me what p has to be. Yeah, p has to be -1. Which tells me that I'm going to count from my vertex, I'm going to count to the left 1 unit. So what's the location of my focus going to be? -4, -1. Questions on that? Where's the directrix going to be? Think about your little sketch here, right? Our parabola opens left, our focus is on the inside. The directrix always has to be what in relation to the axis of symmetry? Perpendicular. So my directrix has to be a vertical line on the other side of the vertex. How far away from the vertex? 1. So it's going to be a vertical line through what value? -2. So my directrix is x equals -2. All right, I want you to take just a second and I want you to kind of talk back through how we got each of those pieces with the people at your table. So re-explain to each other. How did we get the vertex? How did we get the focus? How did we get the directrix? How did we get the axis symmetry? This is your chance to ask each other questions if you're not sure what happened. So go ahead. Okay, what questions do you still have? What have I forgotten to do at this point? Yeah, I haven't actually drawn the parabola. So let's go ahead and do that real quick. 1/4. It's a little wide, not super wide. Make sure you start at your vertex. And you always open towards your what? Focus. Always in the direction of your focus. Okay. Now on these you don't have to graph, but it is important to kind of think about the graph to help you visualize it. Okay? So look at number 3. I want you, take a second, and I want you to draw just a really little tiny sketch of what that parabola is. Does it open up, down, left, or right? Draw it on your paper. Okay, which way does that parabola open? Down. Why? Okay, first tell me how you knew it was vertical. Good. You've got y equals instead of x equals. Your x is being squared. And then we knew it opened down because our a value is negative. Everyone okay with that? All right, cool. What is our vertex? 1, 1. Good. I'm going to go ahead and skip and do the axis symmetry first because that makes more sense. What's our axis of symmetry here? Okay, how do we write an axis of symmetry, though? Good, an equation. X equals 1. All right, now let's find our focus. In order to find our focus, we have to know our p-value. All right, so if 1/4p is equal to negative 1/4, what does that tell us? What's p? -1. Good. So from my vertex, which direction am I going to go to get my focus? Look how it opens. It opens down. So we're going to go down 1. You see why it's important to have this little sketch here to help you visualize it? Remember, your focus is always on the inside of your parabola. So if I go down 1 from my vertex, where's my focus going to be? 1, 0. Good. That's okay. All right. Directrix now. What kind of line is it going to be? Horizontal. It's going to be a y equals. And it needs to be 1 unit in the opposite direction, right, from your vertex. So what would that equation be? Y equals 2. Questions on that? Right. Number 4. Figure out which way this opens. Up, down, left, or right. All right, which way? Left. Good. How did we know it was horizontal? Good. X equals, which means it's horizontal. How do we know it opened to the left? Good. A negative a value told us to open left. Okay. Try and come up with your vertex. Be careful. All right, what do you think? 1, 2. Good. If it helps you, write out the formula. X equals 1 over 4p times y minus k squared plus h. Because remember, your vertex is always h comma k, right? So we get the h value from out here. So that's our 1. And then our k on this, in this instance, is on the inside, which means we flip the sign. So it's a positive 2. All right, axis of symmetry. What kind of line is our axis of symmetry going to be? Y equals, good. Look at your graph. Axis of symmetry still has to go through your vertex. So what's the equation of axis of symmetry? Y equals 2. Everyone okay with that? Give me like a little nod if we're okay. Cool. All right. Focus and directrix now. In order to get those, we need to know our p value. So 1 over 4p is equal to negative 1/12. So what's p? Negative 2. All right, so from my vertex, I'm going to count which way to get my focus. The left 3 units. So if I go left from an x value of 1, 3 units, where am I going to be at? Negative 2, 2. Okay, and my directrix is going to be 2 units, or sorry, 3 units the other way, right? It has a vertical line. So what would the equation of my directrix be? X equals 4. So 2 new things to think about, the focus and the directrix, okay? And sometimes it's going to be horizontal. For your test, you will be given this equation and the vertical equation. But it's not going to say this one's vertical, this one's horizontal. You've got to know which one's which, okay? But it's going to tell you where the h and the k are to help you remember. Okay? Questions? All right, going to get started on our homework.